In order to solve matrix equations, we need to understand a few things first. So we're going to look at the identity matrix and understand what that is. We'll look at the inverse of a matrix, the definition, whether it exists, because it doesn't always, and how to find it by hand for a 2 by 2, but anything else, anything bigger, you'll be using the calculator. And then we'll have a look at how to rearrange matrix equations in order to solve them. So let's start with the identity matrix. Now, this is the matrix version of the number 1. When you multiply something by the identity matrix I, it just equals that original thing. Like 5 times 1 is just 5. And it doesn't matter the order that we multiply in. You can see it's really similar to just multiplying by 1. Now for a 2 by 2 matrix, it looks like this. We have 1s in the diagonal and then 0s everywhere else. For a 3 by 3, we have 1s in the diagonal, 0s everywhere else. So an identity matrix is always square. And we have 1s in the diagonal. And that's it. Now, why do we care about that identity matrix for solving equations? Well, we need to have a look at this. When we multiply a matrix, let's call it matrix A, by its inverse, and we're going to look at what an inverse is a bit later, it equals the identity matrix. That's the same as saying I've got the number 5 and I'm multiplying it by 1 over 5. And that just equals 1. It's like, so an inverse matrix is like the inverse of the original matrix. And by definition, when you multiply them together, you get the identity matrix. And you can see that it doesn't matter the order that we multiply in. Normally, matrix multiplication, it does matter the order, but when we're doing this special calculation, it doesn't. Okay, let's look at the inverse of a matrix. So suppose I have matrix A. Let's look at these elements A, B, C, D. And we're just going to do this for a 2 by 2 matrix. Anything beyond that, you'll use the calculator. The inverse of A can be found by having this scalar out the front. You calculate it by doing 1 over and then using the elements to find this number. We call this number the determinant of A because it's special. And then inside the matrix, you can see that A and D have been switched, and C and B, they're in the same positions, but their sign has switched. So if B was a negative to begin with, it is now a positive. If it was a positive to begin with, it's now a negative. So you just switch the signs by putting a negative in front of it. So let's come back to this determinant, this number that sits under this fraction. Now, in maths, you're never allowed to divide by 0. So if the determinant is 0, it means you would be dividing by 0. You cannot do that. Therefore, the inverse doesn't exist. So it's a really quick way to just check if the inverse exists or not. In order to find the inverse, we need that original matrix to be square. We can only find the inverse of a square matrix. That's something to keep in mind. Now let's look at how we're going to use these ideas to solve a matrix equation. So I've got 2 situations here. One where my unknown, the X matrix, is my unknown. One where A is multiplying before, so it's a pre-multiplication, and one where it's multiplying afterwards. And we deal with both of these in slightly different ways. So you know that to solve an equation, you do the opposite operation of what's happening to X in order to remove it. So if I had 5 times X equals 10, I would divide both sides by 5, because that's the inverse of multiplying by 5. And then I calculate this, it equals 2. For matrix equations, it's a little bit different. Our inverse operation of multiplying by A is to multiply by the inverse of A. And I have to do it on both sides. Now notice A was on the left of X, so my inverse goes on the left. On both sides, it always gets put on the left. Now, as we saw above, the inverse of a matrix multiplied by that same matrix just gives us the identity matrix, which is the matrix version of 1. So we just have X there. And so then this is something you can put into your CAS calculator or by hand. You could calculate it by hand. But this, as it stands, a matrix equation, we cannot solve that on the CAS as it is. We do have to rearrange it into this form first. And then we just put that bit into the calculator. Okay, so when we have a post multiplying over here, we do a very similar thing, but we're going to post multiply the inverse on both sides. So if A is on the right, we multiply the inverse on the right. That turns into the identity matrix, which kind of just disappears. We don't need to write it. And then this is something we can solve, we can calculate on the CAS or by hand. And that's done. We can have more complicated ones. So suppose we had A times X plus C equals B. Now, just as we had like 5x, if we have a plus 2 equals 10, then we have to remove that 2 first by doing the opposite or the inverse operation of adding. It would be subtracting, and then we divide by 5. So similar thing here. We need to move the C across, so we'll do B minus C. And then we're going to multiply by the inverse of A, and we have to do it on the left because A is on the left. We're going to get X there, but inverse A here, and I need to put in brackets because it has to apply to that matrix we've already got there, B minus C. What if I had X times A minus C equals B? We have to remove that C first. We're going to do that by adding. And then we're going to remove that A by doing the inverse of A. It will disappear from the left, but it will appear on the right, and we have to place it on the right. And that's it.